Hi there, Physics 131. I want to go over the reading for class 15. Let me just share my screen here, and I'll show you. Okay, so it's basically just the last part of chapter 5. So this is called the law of universal gravitation. It seems a little strange, but we're going to talk about orbits basically. And so the idea is that I guess I'll scroll to this tip here. You might be wondering why, if the Earth pulls on the moon does not come closer to Earth in the same way that an apple falls from a tree. The difference in these two cases is the speed of the object. The apple is at rest with respect to the Earth before it leaves the tree, but the moon is traveling tangentially. So think of what would happen to the moon if the Earth stopped pulling on it. It would fly away in a straight line. So not only does the Earth's gravity pull the moon towards it, it's actually what is needed to keep the moon orbiting the Earth, even though it doesn't get any closer. So there's an equation here. It comes up a couple of times, but basically it's the universal law of gravitation. Sorry, I'm scrolling a lot here. Where is it? Okay, here it is. The force of gravity of 1 on 2 is capital G times m1 times m2 divided by r squared. So this is an attractive force between any two objects, mass 1 and mass 2, whose centers are separated by a distance r. The force of gravity between them is this, where this constant G is 6.67 times 10 to the minus 11. Newtons per kilogram squared times radius squared. And they work it out for a ball. So if you've got a tennis ball, it's 50 grams, how does the gravitational force of the Earth act on that object? Well, according to this gravity force, you've got the two objects are mass of the Earth and the mass of the ball. What's R? Well, R is the distance between the center of the tennis ball and the center of the Earth. So that is actually 6.4 times 10 to the 6. It's the radius of the Earth. So what you do is you plug in this, for all these equation numbers here, you plug in that universal constant, 6.67 times 10 to the minus 11. You plug in the mass of the Earth, which is 6 times 10 to the 24 kilograms, the mass of the tennis ball, or whatever it is, I guess, and then divide by the radius of the Earth squared. And what you always get is 9.8 times the mass. So this whole equation boils down to 9.8 newtons per kilogram times the mass of the ball. So that's where the 9.8 comes from. It comes from the mass of the Earth times capital G divided by the radius of the Earth squared. So that's good to, there it is. A of the object is given there. There's a little bit about Kepler's first law of planetary motion as a planet orbits the sun. The reason for that is that the sun is pulling the Earth or the planet towards it with this gravity force. And it goes through the 3 laws of Kepler's of planetary motion. There again is universal law of gravitation. That's a good one to know, where the little g comes from. It talks about weightlessness of astronauts. And I think, again, that's probably all you need to know for today's reading. And I'll see you Friday. Okay, bye-bye.